Let's take a look at converting recurring decimals into rational numbers, or just basic fractions if you like. Now to do this, and there's a bit of a trick really to making this all happen, the first thing we need to do is having a look at the number, and in this case we're going to do, I'll start with 2a, which is 0.05 recurring. So if we were to write that out, it's important to actually see what it looks like. That of course is 0.0555, and so on. So we're going to want to cancel some of these, leaving only a decimal. So the most obvious thing to do here is simply to multiply both by 100. So let's call x 0.0555 and so on. So if x is 0.555, if I was to multiply this by 100, I get 100x is equal to, and this would become 5.5 recurring. Now, the challenge we face with, of course, with that is we end up with, if we were to say 100, let's say we were to subtract x from both sides, subtract x from here and x from here, this would become 99x. And this would become 5.5. I'm actually going to write this out so you can kind of see it. Yeah, and there it is. And of course, x was 0.0555. So that didn't work out quite as we wanted, in fact. If we subtract these two, we end up with 99x is equal to 5.5. And, well, we're really looking for something a little bit different. So if I was to multiply both of those by 10 now, we would get 990x is equal to 55. Now, of course, we can deal with rational numbers a little bit more easily. And I can divide both. I can divide both of them by 990. Of course, I'm left with x is equal to 55 on 990. And of course, if you want to use a calculator here, not a bad thing to do. Let's have a look. 55 over 990, and what do we end up with? 1/18th, and that works well. Now, of course, there was other ways of doing this as well, and probably one of the more useful ways was to actually not multiply it just by 100. But let's say we multiplied it by 1,000. Well, let's have a look at how that would have played out. So if we've got x is equal to 0.0555 and etc. And I'm going to multiply this by 1,000. So that's x. If I go 1,000x, then I'm going to end up with, what's that? 1, 2, 3. 55.555 and so on. Yes? Now that's that. But what about making x here something useful? I want this actually to be just 0.55. So why not multiply x by 10 as well? So I could say, well 10x is equal to 0.5555. So I've got 1,000x and I've got 10x. Well, if I was to subtract these two, 1,000 minus 10x, of course, is 990x. And 55.5 recurring minus 0.5 recurring is just 55. Now I could divide both sides by 990, and I've got x is equal to 55 on 990, which is 1/18. So a couple of different ways of approaching the same problem.